CIT 1121, Module 11, Submodule 2, IPv4 unicast, broadcast, and multicast addresses. There are three types of messages that you can send, and they are listed right here. Let's go ahead and get into them. Unicast is the way that we're usually going to send data, right? I have information that I want to send to another device, or I want information from another device. I think I'll ask that information to send me something. Perfect. Standard data communication, unicast addressing. Unicast, single IP address as the source IP in the packet header, single IP address as the destination IP in the packet header, and information goes from point A to point B. In this case, device 4.1 wants to send information to the printer at 4.253. No big deal. Source and destination are posted as unicast values. And this is how we get most things done. So most devices are trying to unicast into another device. At times, we will send broadcast messages from one device to another. So it's possible that you might want to send a message to everybody else that's in a subnet. For instance, the most popular thing that we've talked about in this class is ARPing. And the very first part of ARP is something called a broadcast ARP, which everybody's aware of, which means I'm going to send traffic to a whole bunch of devices, and I'm going to send a broadcast to them. Now, that's similar to what we're going to see here, but in IP at the packet layer, the destination value is going to be all 255s instead of in the ARP MAC address frame header, which is going to be all Fs. We're just going to send a message to every device that's on our network. Hey, every device on our network, I'd like for you to be aware of what we're doing here, and it is a broadcast message that you're going to send to all the other IP addresses in that particular subnet. Now they've shown destination here 255, 255, 255, 255, and we just talked a second ago about how broadcast address in a given subnet is usually the last address in the range. So let's just cross that one out here for a second, and let's just write in here 172.16.4.255. That might be a little bit more accurate for this particular network because we're seeing the source as being this, and we're going to send out a broadcast message to all the other devices that are on my LAN, and look at the devices that get this. Now notice there's nothing up here or up here. There's nothing out here, right? And that's okay because the barrier for a broadcast message is at the router itself. So when a device sends a message and it's going to be broadcast, it's going to go to all the other interfaces that are on that particular subnet, on that particular network. So it'll go to this router interface, but it'll never go past that. This router's not going to go, hey, it's broadcast. I wonder if we could get the answer for it on this other network that I'm connected to, or this other network I'm connected to. That's not going to happen. So just be aware of that the broadcast message is confined, just like it is with a broadcast message that was like a derivative from a broadcast from a destination MAC address being broadcast. If a destination IP address is being broadcast also, you are not going to send that across the router. Okay? The third type of transmission is known as a multicast. And these are usually used with things like streaming audio or streaming video, or a lot of your printers will use multicast addressing to make an initial configuration. So they'll be listening on a specific multicast address, and any device that wants to communicate with them, they can learn all kinds of great stuff about that particular printer by connecting to that multicast address and having it send information back. But in most cases, the multicast is a transmission that's going to be sent from one device, and then it'll be repeated when necessary, the last possible place necessary. So in this case, we've got 4.1 is sending out a multicast. The devices that have subscribed to this multicast that want to receive it are devices 10.5 and 4.3 and 4.4. And they're both listening on the same multicast value, and they've told the switch, we're interested in that particular multicast. We've sent join messages, and it's going to duplicate that, whatever that message is from 4.1, it's going to duplicate that for both of these guys. So these two devices are going to receive that information, but anybody with an X on it is not going to receive that. Now, if let's suppose, just for grins, 4.4 sends a leave message, it would leave the multicast, and it would no longer go there. And if 4.2 sent a join, it would then start, and then it would be these two devices receiving the information. So multicasts are based on the last intermediary device, router or switch, receiving it and identifying if there's any hosts that need the multicast on that particular interface. If there is, it sends it over to it. If there isn't, then it doesn't. Just like it did here, the switch did here for this particular communication. First, two devices were interested. They both had sent join messages to the switch and said, "I'm interested in joining that. I'd like to see that particular stream." Then one left, sent a leave message, and it left. And then there was one, and then a different device joined, and then there was back to two again. So it duplicates at the very last possible device.